All right, let's just jump right in. For the better part of a century, we've had this incredibly successful, but also deeply complicated way of describing how the universe works on the smallest scales. But what if all of that complication was just a shadow? What if the real rules of the game hiding underneath it all were shockingly simple and just breathtakingly beautiful? Well, today we're going to break down a revolution in physics that suggests exactly that. See, to really get this new revolution, you have to appreciate the old way of doing things. The standard method, the one that won Richard Feynman a Nobel Prize, involves calculating what happens when particles smash into each other using these things called Feynman diagrams. You start with this big master equation, and from it, you have to draw out every single possible way that particles can interact. It's absolutely brilliant, but as the physicists Elvin and Huang put it, the whole thing just explodes into an inferno of indices. And that inferno, well, it's really at the heart of what you might call physics' most beautiful, yet absolutely awful calculation. And just look at how quickly things get completely out of hand. Take gluons. These are the particles that literally glue atomic nuclei together. If you want to calculate what happens when two of them collide and create two more, you need to work through 4 of those Feynman diagrams. Okay, that's manageable. But what if you add just one more gluon to the final result? Suddenly, you're at 25 diagrams. Add another, 220. And if you want to see what happens when 2 gluons create 8, you are looking at over 1,000,000 diagrams. 1,000,000! And you have to remember, each one of those 1,000,000+ diagrams is its own complicated piece of math. Trying to add them all up is, as our source material says flat out, an awful, uninsightful, and in many cases, impossible job. You don't get any real intuition for what's happening, you just get totally buried in algebra. But here's where the story gets really wild. After all of that brutal, painstaking calculation, something almost miraculous happens. Physicists would spend months, sometimes years, slogging through thousands of pages of calculations. And that term you see, on-shell scattering amplitudes, that's just a fancy way of saying the final physical result you can actually measure in an experiment. And despite all that horrible complexity, that final answer would just collapse down into a single, beautiful, elegant line. This was the big mystery. So you have this absolutely massive disconnect. On one side, you've got a computational nightmare with millions of parts. On the other side, you have a final answer so simple and clean it could fit on a Post-it note. This enormous mismatch was just screaming that we were missing something really fundamental about how reality works. And that brings us to the question at the very heart of this. Why was the established Nobel Prize-winning method so unbelievably hard when nature's own answers were so simple? It felt like we were using completely the wrong language to ask the question in the first place. So the search for a better language led to a whole new way of thinking in physics, a movement that's often called the Amplitudes program. The new idea was pretty radical. It was like, hey, if the starting point, that big master equation, and all the steps in between are the source of the mess, what if we just skip them entirely? Instead of building everything from the ground up, this new approach said, let's just focus on the final answer itself. Specifically, physicists decided to focus only on what they call on-shell amplitudes. Now, on-shell is basically physicists speak for things that are real and physically observable, the actual particles that you can detect in a collider. Feynman's old method was filled with these virtual particles, sort of mathematical phantoms that only exist in the equations. This new idea threw out all the ghosts and just focused on reality. Now, to do this, they had to invent a whole new mathematical toolkit. We won't get lost in the weeds here, but names like spinor helicity, recursion relations, and unitarity, these represent a whole treasure chest of new ways to build the answer directly, without ever having to draw a single one of those old school diagrams. And when physicists started using this new language, what they found was more profound than anyone had even dared to imagine. It turns out the reason the old method was so complicated wasn't that the physics was complicated. It was that our description of it was. We were basically describing the shadow on the wall, not the actual object casting it. And this is the big reveal, the whole show. Particle interactions, when you get right down to it, aren't about this ridiculously complex web of calculations and virtual particles. At their very core, they are expressions of pure geometry. So what does that actually mean? It means the chance of those gluons scattering isn't found by summing up 1,000,000 diagrams anymore. Instead, it's the exact same thing as calculating the volume of a beautiful geometric object called a polytope. Think of it like a multidimensional jewel. The math for these shapes comes from really abstract fields, but the answer is clean. That messy physics problem was secretly a simple geometry problem in disguise the whole time. But believe it or not, the story doesn't end there. This geometric key didn't just unlock particle physics, it revealed a secret about the biggest force in the entire cosmos. Because once physicists started to see reality in this new geometric light, they spotted a pattern that had been completely invisible before, a connection that could one day unify our understanding of, well, everything. And this is it. In this new language of amplitudes, the force of gravity looks like the square of the other forces, the ones that govern particles, which physicists call gauge theories. I mean, just look at that. This equation is one of the most exciting and provocative discoveries in theoretical physics today. And what this implies? It's just staggering. The interactions of gluons, the strong force, are described by one kind of math. The interactions of gravitons, the particles of gravity, are described by what looks like two copies of that gluon math just stitched together. So gravity, the force that shapes entire galaxies, might just be a kind of echo of the forces that shape atoms. So all of this leaves us with a truly profound question for the future. We started with these incredibly messy equations that somehow gave simple answers. Then we found out those answers were really just describing simple geometric shapes. So the question now is, can we flip our entire understanding of physics on its head? Can we start with the geometry as the fundamental truth and derive everything else from there, building a whole new picture of reality right from the ground up?